So area V will be number 3.11, 2 legs, so 0.22 inches square. That's fine. And check relationship between V ultimate and phi VC divide 2. Wow. Phi VC divide 2 equal 9,450 pound. And your V ultimate equal 472, which is smaller. That means no stirrups are required. No stirrups are required. You can say no stirrups are required. Why? Because V ultimate, which is from shear force diagram, smaller than phi VC divide 2, but we will use minimum with spacing 24 inch. 24 inch is the maximum. You cannot exceed this value. And your problem is done.
AISC says 24 is the maximum.
Yes, 24 is the maximum. Second example. We have uniform, we have a beam, design stirrups for the assembly supported beam as shown, use number 4 stirrups. The supports are 12 inch wide and the loads shown are surface load, beam cross section is shown, FC prime and FE. Okay, we have dead load, we have live load as a distributed load. So W ultimate equal 1.2 times your dead load 2.5 plus 1.6 times your live load 3. Your value will be
V ultimate, right?
I'm sorry?
V ultimate or
W ultimate. W distributed load. I'm still distribute because your dead load and the live load is still distributed load. So your value .8 kb per foot. So we are right now in a simply supported beam with the span. What is the span? Are you sure? 24 feet from face to face of your column. But actually the actual span must be from center line to center line of your support. So what is the actual distance between center line of your column to center line of your column? It's nothing but we have 12 inch wide. This wide is 12 inch. So we have here 6 inch and we have another 6 inch here. So the total will be 25 feet. One more time. Your support or your column width 12 inch. Your distance 24 is measured from here. We would like to measure our span from center line. So we need to add 6 inch from this side and another 6 inch for the other side, which is 1 feet. Anyway, we have uniform distributed load from dead and live equal 7.8 ultimate kb per foot. Nothing else, only distributed load. Okay, your equivalent force will be 25 times 7.8 your equivalent force will be 195 kip. So your reaction here and your reaction there will be what?
195 divided by 2. 97.5.
97.5 kip. 97.5 kip. If you would like to draw your shear force diagram, go up 97.5 kip, dot it, you hit this value, go down to 97.5, keep going dotted, close to 0, then draw inclined line, positive, negative. Here is your shear force diagram. What is the value of V ultimate? What is the maximum value? Regardless, what is the sign, positive or negative? 97.5 kip. First step. Go ahead for the second step. Phi VC equal 0.75 to B web depth square root of FC prime. So 1.5 times B web. What is a B web? 16 inch. Your depth. What is the depth? It's not given. Not given.
3 inches. 27.
Cover is given? No. So you can assume your cover 3 inch, 2.5 inch, that's fine. So, okay, 27 inch. Square root, FC prime, 3000. Remember, your 3000 in pound and inch square. So your value will be in inch, in pound. What is the value?
33.274.
Okay. 35,000. 492 pound. Okay, keep everything in kip. So divided by 3, 35.5 kips. What do you think? Okay. Phi VC divide 2 equals 17.25 kip. However, your V ultimate equal 97.5, which is greater than Phi VC. What is the situation right now? Your V ultimate smaller than this value? No. That means we need stirrups. Okay, go ahead and tell me what is the relation between V ultimate and this value and this value. Do you think we are in between?
No.
No. Do you think V ultimate is greater than Phi VC? Yes. V ultimate, which is 97.5, I think greater than Phi VC, which is 35.5. So we are in this case. Okay, go ahead and calculate your VS, which equal V ultimate 97.5 divided by Phi minus what?
VC.
VC. What is the value of VC?
35.
No. No. 35.5 is Phi VC. If you would like to get VC only, divide this number by 75. 47.33. Your value of VS equal 82.67 kip. Then your spacing of stirrups equal. But before spacing, number 4, 2 legs. So number 4, 0.2, 2 legs. So 0.4 inch square, which is AV. That's right. So S equal AV 0.4 time F yield. What is the value of F yield?
40,000.
40,000. Depth 27 divided by VS, which is 82.67 times 1,000. Don't forget 1,000. Why?
You return it back.
Because this one in kept and you used 40,000 in pound per inch square. So we need to make your unit consistent. So 0.4 time your S will be 5.2 inch.
You can make it smaller, but you can't make it bigger. Like I could say 5 inch.
Yes, yes. 5.2 inch. If you would like to round your number to integer number, you can make it 5 inch. Because 5 greater than 5.2 will be unsafe. So finally, this beam under this condition of load will have stirrups number 4 at 5 inch.
I have a question.
Yeah?
Why don't they put in the middle sometimes?
Say it again.
Like stirrups in the middle,
In the middle.
like, because there's no shear?
Here?
Uh-huh.
No, you
no,
can.
No, like, the spacing, it's supposed to be 5 inches, and sometimes you'll see like every 5 inches, but only at the edge.
Okay. Can you watch this one? Can you watch it?
Mm-hmm.
V ultimate equal 97.5 where?
The edge.
It's not economic to make your stirrups at 5 inch everywhere, even you don't have shear. Okay? So if you would like to get more economic solution or more economic design, hey, at this location I need stirrups every 5 inch. But after this distance, your shear force becomes smaller and smaller and smaller. So I will make my stirrups spacing bigger and bigger and bigger. You know, it's more complicated because your shear is variable every single inch. But we would like to make our life easy in this course, you know. But from shear force diagram, you can decide which distance I need to put more stirrups and which location I don't need. You got it?
Mm-hmm.
Okay.
Dr. Amy, can I follow up on that one? So if we added the 4 legs there, would that increase to 10 inches?
Yeah. If you would like to increase this distance, you feel 5 inches very small, so you have 2 options. Maybe you can make your size of stirrups bigger. Maybe not this option is available all the time, or increase your legs. Rather than 2 legs, 3 legs, or 4 legs, you will increase your AV and then decrease your space. Increase your space.
Is there a minimum spacing?
Yeah, there is maximum spacing, but minimum spacing, there is no structure reason for minimum spacing. Minimum spacing depend on something called on maximum aggregate size. Do you know this expression?
Yeah.
If you go back to your concrete design, concrete, not reinforced concrete, no, concrete mix design. You have gravel, you have sand, you have cement, you have water. For gravel, you have different size of your gravel. That's right. The maximum aggregate size, maximum size of your gravel has a relation with the minimum spacing between stirrups to prevent nesting of concrete. Okay? So based on design of your mix concrete, you can decide what is the minimum distance or what is the minimum spacing of steels. So design of shear is a very simple method and very easy, and we have only one case without any different case like bending. T-section, double reinforced section, single reinforced section, and all of this stuff. Just quick hint about torsion. If you have curved beam, you can expect torsion on this beam. I'm sorry, I cannot understand what is the meaning of torsion. Torsion is twisting.
Torsion is a twisting action about the longitudinal axis of a member. Since one end is twisted while the other is held fixed, shear cracking and stresses are created in the member due to torsion. By examining a small section of this member, it's easy to see the shear forces acting. If you recall the diagram of the stresses from an applied shear load, they look very much the same as these stresses produced by torsion. Unlike the response due to shear loading, torsion produces shear stresses in opposing directions on the opposite sides of a member. The effects of torsion also create tensile stresses which can crack concrete. These diagonal torsion cracks will wrap around the member as shown. In a member without embedded steel reinforcement, cracks would propagate through the specimen, causing it to fail. Therefore, transverse and longitudinal reinforcement is provided uniformly around and throughout the entire specimen. Once the concrete cracks, the tensile forces are then resisted by the reinforcement, and thus the ultimate torsional capacity depends on the amount of provided reinforcement.
So torsion means